Hey, welcome back. In this video, we're going to redo an example from class. But before I start that example, I just want to reiterate how important it is that you prove your answers, justify your answers on an exam. So everything we're doing now, the assignments that you have this week and next week, you should be answering those questions by justifying them in your notebook, of course. When WebAssign asks you to determine if something's a vector space, you're actually proving on your paper that it is or is not a vector space, and then you enter your answer on WebAssign. So when WebAssign says determine whether a set is linearly independent, you actually have to prove that on your paper before you enter your answer on WebAssign. So I hope you're all doing that because you're getting practice for the exam. On the exam, I won't ask for an answer. I'll ask for an answer, but really what I'm grading is your proof. So practice, 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 so that when you take the test, you know exactly what you're doing. So I'm going to redo this example from class. I made a minor mistake, and I really went too quickly anyway. Let's see if you can figure out what the mistake was. It wasn't a big deal. So what we did was we determined whether this set with two polynomials is a linearly independent set in P3, the vector space of all polynomials of degree at most 3. So we have to use the definition of linear independence. You'll see in the next two videos an alternative to that, using a test for dependence and a corollary to that test. But right now, we're going to use the definition of linear independence to prove that this is, in fact, a linearly independent set. And so this is the kind of proof you'll be expected to do on your test. So what we do is we suppose that there's a linear combination of these two vectors. So linear combination is a sum of scalar multiples of the vectors in the set. And we assume there's a linear combination that will give us the zero vector in that vector space. And remember what that symbol means. The zero with a hat on it is if it's typewritten, it's a boldface 0, but when it's handwritten, we have to put a hat on it. It doesn't mean 0, and it doesn't mean an ordered pair of zeros. It means the additive identity element of that particular vector space. So in this vector space, that means the zero polynomial of degree 3. So I'm going to rewrite the equation so that the zero vector is written as a polynomial in that vector space. So the additive identity element in P3 is 0 plus 0x plus 0x squared plus 0x to the third. All right, so now what we want to do is see if that linear combination, those coefficients have to be zeros. Both of them have to be zeros. If they do, then that means it's a linearly independent set. If they don't have to both be 0, if there are non-trivial solutions, then it's a linearly dependent set. So let's distribute the coefficients and then combine our like terms. So my constant term ends up being 5c2 minus c1, and then my coefficient of x is 2c2, and then I have a coefficient of x squared, which is just 4c1. And that's all equal to that zero polynomial on the right. All right, and so now we want to find out what C1 and C2 have to be. Let's equate the corresponding coefficients. So 5c2 minus c1 has to be 0, because on the right the constant term is 0. The coefficient of x also has to be 0, because the coefficient on the right is 0. And then the last one is 4c1, the coefficient of x squared, that one has to be 0. And we don't have an x to the third term, so we don't have a fourth equation. So we have 3 equations, 2 unknowns, and we can see from the last equation that c1 is definitely 0, and the second equation tells us c2 is 0, and that's it. We only got the trivial solution. So what we've just done is we've just proven that this is in fact a linearly independent set of vectors in P3. All right, so that's a short proof, but that's the kind of proof you should be doing in your homework and you will be expected to do on your next test. I'll see you in the next videos.